Section 8.1 in Chapter 2, Part 1 video. In this system, or in this section, we'll be looking at systems of equations. Systems of equations have three types of solutions. And looking down at the graphs below, you can see the three types of solutions that are possible. The system of two equations, we're going to graph them. We're not going to solve them algebraically by substitution or elimination. We're going to graph them, and that's going to tell us what we have. Now, if it's a dependent system, then all the solutions of one equation are also solutions of the second, meaning that they are the same line. So if you look at the first one right here, it says line 1, line 2, and you only see one line. That's because the second line lays right on top of the first one. So we call this a dependent system, the first one here. Okay, so this is a dependent system. The second one is what's called an inconsistent. That means that the lines are parallel. Okay, inconsistent. And then the third one is consistent and independent. Okay, that means the graphs of two lines intersect at exactly one point, and that one point is the solution. It contains an x and a y. Okay, this particular two parallel lines is inconsistent. We normally would say it is a no solution, right? And we can also say that this dependent one, which is the same line, has infinite amount of solutions, right? Okay, so that's kind of 2x2 systems in a nutshell. The first problem we come to, it says, okay, solve the system using a graph. We'll verify that your solution satisfies both equations. Well, if you can look at it, it intersects right there at 4, 2. So what we're going to do is, for it to satisfy, that means when we substitute the x and the y back into the equation, that the left side will equal the right side. So we're going to say 2.3 times 4 minus 3.7 times 2. Does that equal 1.8? Then we're also going to check 1.1 times 4 minus, or plus, I should say, 3.7 times 2 equals 11.8. So 2.3 times 4. So 2.3 times 4 plus, well, hold up, 2.3 times 4 minus 3.7 times 2. And that is 1.8. Does that equal 1.8? Verify. So the bottom one, 1.1 times 4 plus 3.7 times 2. And that gives me 11.8 equals to 11.8. Verifies. So yes, it does satisfy both of them. Now, let's look at this one. Graph the system by hand using the intercept method, or just to identify it as a dependent, inconsistent, or consistent and independent. So what we're going to do, first thing, is we've got to give them in slope-intercept form. Okay, that's your x, that's your y. If you think about it, then we have -7. I'm going to go ahead and just change them to y's equals -3x plus 14. Okay, and then we'll divide both sides by -7. So we have y equals to 3/7 x minus 2. So that's the top one. Now let's do the bottom one. That would be 3x plus y equals 6. And then if we move this x to the other side, we have y equals -3x plus 6. Now, I changed them to x and y just because it's a lot easier for me to deal with it. It's probably going to be a lot easier for you to deal with it. Okay, so let's graph these. Okay, we're going to graph the first one or put it in, and then we'll go grab the second one. So we're going to go y equals. We're going to clear out anything that's there. I'll go ahead and clear that. Now let's go back and 3/7 x minus 2. So parentheses 3 divided by 7, close parentheses x minus 2. That's in y1. Now y2 we'll put negative 3x plus 6. So negatives down here, 3x plus 6. And then all we're going to do, I don't even know what let's just look at, I got a negative 30 to a positive 30. We'll leave it like that, okay? And just hit graph. Well, I don't, excuse me, I don't see the second one. So I'm going to hit zoom 0 just to, okay. Now, the reason I put zoom fit is it graphed them based just off the x's, okay? And it used the scaling of the y's that it was there. So when I hit zoom fit, it set my y values, my y window, to fit the outputs that I have in both of these. And you can see that they intersect, right? Now, if I want to see where they intersect, all I have to do is hit second trace and go to 5, not 6, sorry. Second trace 5, enter, 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 and we see that they are 2.33 and negative 1. Now, it said, is this a dependent, inconsistent, or consistent and independent? Well, it would be, because it crossed, it would be the consistent and independent. Okay. Now, let's look at another one. Excuse me. We're going to do the same thing. These are x and y, so we ain't got to worry about that. So we're going to put everything back in slope-intercept form. So I'm going to take that 6 to the other side. So y equals 2x. If that's a positive 6, when I take it to the other side, it's got to become a negative 6, right? Now, let's move this over. So we got negative 4y equals negative 8x minus 32. And then let's divide by negative 4. We have y equals 2x plus 8. And a negative negative gives you a positive. Now, I want you to see something real quick. See the slopes here? I know that these are going to be parallel, okay? Which means that they are inconsistent. We can go back and show parallel is inconsistent, right? Slopes are the same, but we're going to graph it just to prove, okay? That's what we're going to do. So let's go, let's clear out this. Let's go back to y equals and kind of hit some clears here. Alright, so let's look at the first equation. 2x minus 6. So 2x minus 6. Alright, and I have a 2x plus 8, I think, right? Yep. Alright, now, I'm just going to hit graph. Okay. And I can tell that they are parallel. I identified that they had the same slope. Okay. So that verifies that this one is inconsistent. Now, let's look at another one. Alright, so we again going, I don't like the L's and the W's, so I'm going to say X and the Y's, right? So on the first one, I'll have 2x minus 7y equals negative 18, right? And then I'll minus 2x. So I get negative 7y equals negative 2x minus 18. So I'm taking it over in the slope-intercept form, right? So divide by, oh man, that looks bad. Those 7's all run together there. So divide by negative 7. Everything. So that leaves me y equals 207x plus 18 over 7. Okay, now let's look at the bottom one. So that's 21 over 2x minus 27 equals 3y. Everything's good except for one thing. No, hold up. Let me back up. Because I just made a mistake. I just grabbed the wrong ones. Okay, so let me do this. The W is a Y. And then the L is an X. So be careful about when you switching these. Sometimes you just got to double check. Alright, so I'm going to take 27 over. So that's going to leave me 21y. 21 over 2y equal to 3x plus 27. Okay, so what I'm going to do is this. I'm going to basically multiply everything by 2 over 21. Okay, and what that's going to give me is y equals 6 over 21 x plus 2 times 27 is 54, I think, right? 27 times 2, yeah, 54. 54 over 21. Now, let's simplify this. I know I can pull a 3 out of both of those, so that'd be y equals 2 over 7x. And if I pull 3 out of those, that leaves me with this. And we can see that these two are both the same line. So it would be independent. I wouldn't need to graph it to do it from there. Okay. So what we've done is we've looked at systems of equations. We've identified that there's 3 answers. One where they intersect, one that's parallel, and one that's the same line. Now, and we've worked each of the types of examples, and we've graphed at least 2 of them so you can see. All right, so this concludes section 8.1, part 1's video.